Hello everyone, welcome to today's class. In today's class, we are going to look into division of surds. Now, let's go. Say if a fraction has a surd in the denominator, it is usually best to rationalize the denominator. Take note of this word, rationalize the denominator. We are going to come into that when we start solving. To rationalize the denominator means to make the denominator into a rational number, usually a whole number. To do this, multiply the numerator and the denominator of the fraction by a surd that will make the denominator a rational number. So let's get down to it. First, I'm going to explain what we mean by rationalizing. We all know what rational numbers are. We did in our first class. Rational numbers are numbers that can give a rational value, like a whole number or a decimal that has a decimal that has an end, but irrational number are the ones that that have a recurring decimals. Now, first, this is a surd that the surd is on the denominator of the fraction. This is a fraction that has a surd on the denominator. So what we mean by rationalization is make sure that this denominator is a whole number. When solving for surd, it's not always advisable to leave a surd in the denominator. We always want to take it up and make the denominator a whole number. Now, this is 6√3 for the first example. We all know that any surd that multiplies itself gives us a whole number. What do I mean? Let me give you an example. If you have square root of 2 and multiply it by another square root of 2, it gives you 2. How? Because when you have something like this, you have something like square root of 2. Let's say square root of 2 multiplied by square root of 2 is the same thing as square root of 2 multiplied by 2, which is the same thing as square root of 4. And the square root of 4 is 2. Subsequently, any number like x, let me use a variable x so that it can cover every other number. Square root of x multiplied by square root of x will give you x. So this x will stand for any number at all. So coming to this example A, 6 over square root of 3. For us to make this denominator a rational number, what we are just going to do is make sure that we multiply this square root of 3 by another square root of 3, so it will now give us a rational, which is 3. So in doing that, all we need to do is just multiply this by square root of 3 over square root of 3. How do you get about this? Square root of 3 over square root of 3 is the same thing as 1, and any number multiplied by 1 is still the same number. You just say something like x times 1 is equal to x. So by multiplying this by this, we have not changed anything. We are still having the same value. So the up, that's we're now solving for example A. The numerator will now be 6 root 3, because the numerator will multiply the numerator, the denominator will multiply the denominator. So this will be square root of 3 times square root of 3. So the answer will now be 6 root 3 all over 3. If we are to apply this rule, that any surd that multiply itself will give you the surd. So now, is this the final answer? No, because 3 can divide by 2. So the final answer is 2 root 3. Now, this is our final answer. If you are going to point your calculator, this is a irrational number. You are going to find out that this is equal to this. But why do we prefer this? Because this does not have a denominator that is a surd number. Now we have a denominator that is 1 in this case. So this is what we call rationalization, trying to remove the surd from the denominator. This is a second example. We have 7 all over root of 18. So we are to to rationalize this and make sure that this surd is out. But now this root of 18 can also be simplified because this is not the final what do you call it, the smallest irrational surd. So something can be done into this. So first of all, we rationalize before we simplify the denominator itself before we rationalize this surd. So first, what we are going to do is we are going to have 7 over, this is 9 times 2, which should give us 7 all over square root of 9 multiplied by square root of 2, which should give us 7 all over 3, because square root of 9 is 3, and we are still left with 2. So this has been simplified. This is now what we are going to rationalize. So take note of that. If you can still rationalize this surd, rationalize it first before you start your simplify it first, sorry, before you start your rationalization. So now what are we going to use to rationalize this? What we have in the denominator. Take note, the denominator is what determines the multiplication factor. So we have 7 all over 3 root 2 times, so whatever we have in the denominator is what we are going to multiply both the numerator and the denominator. So in this case, we are going to have 7 times 3 root 2 all over 3 root 2 times 3 root 2. Remember the rules of multiplication that we used in the previous class. The whole number will multiply the whole number, while the surd will multiply the surd. In this case, we only have 3 times 7 in bracket root 2, all divided by, now this is 3 times 7, 3 times 3 and 2 times 2, so it will be 3 times 3 square root 2 times 2. So we are going to have 3 times 7 is 21. The numerator will be 21 root 2 all over 3 times 2 is 9, while this is 2, because 2 times 2 is 4 and square root of 4 is 2. So the final answer will be 21 root 2 all over 18. This is the answer. But since we can still divide this answer, so we go on. 3 divide 21. 21 divided by 3 is 7 root 2, while 21 divided by 18, sorry, 18 divided by 3 is 6. So this is our final answer. This is not the final answer since we can still divide it further. So let's solve the final example, which is example C. For rationalization, we're trying to deal with rationalization. So the answer, we have 5 divided by root 5. So in this case, this denominator is already in the final rationalized form, so we are going to just go on and solve it that way. So it will be 5 divided by root 5. So what are we going to multiply? Yes, root 5, all divided by root 5. So here we have 5 root 5 for the numerator, and then we have the answer here is supposed to be 5 because a surd multiplied by itself is that surd, as we showed in the previous example. Let's just solve it further, which is 5 root 5 divided by root 25. Square root of 25 is 5, so we have 5 root 5 all over 5. So we now divide 5 by itself. Our final answer is root 5. So this is how to rationalize a surd. Now let's dive into division of surd. So these are the few examples we are going to do. Root 18, for those that can't see it properly, this is root 18 divided by root 2. So for number A, we have root 18 divided by root 2. So we have to divide this. Now, if you remember in our previous class, we made it clear that, let me use a variable, that if you have root y divided by root x is equal to y over x, or in one root. So let's apply that rule here. This root 18 divided by root 2 will now be equal to 18 over 2, or in one root. So this will give us root 9, because 18 divided by 2 is 9, and square root of 9 is 3. This is your final answer. Let's go to the second example. Root 5 divided by root 2. In this case, we have also to apply the same rule, that this will give us root 5 over 2, which will also give us root 2.5. So this root 2.5 is simply it is a decimal surd, but most of the time we don't leave our surd in this form. We usually leave it as a whole number. So what we are going to do here is just simply, since this cannot divide this and give us a perfect square, we'll still leave it in the initial form that it was, which is root 5 over root 2, and just rationalize it. So to rationalize, root 2 is what we are going to use for division, for the factorization. So this will now be equal to, remember the rule, 5 times 2 all over, this is already 2. Let's not be solving long. This is already 2. So we have root 10 all over 2. This is our final answer, because now we've rationalized the denominator. The most important thing in sort is always make sure that the denominator is a rational number. So let's go to the next question, which is question C, which is 16 all over root 7. Then we apply our rule. This is the same thing as 16 over 7, or in one division. But as you can see, there will be no meaningful division here that will give us something we can use. So what we are going to do is to just rationalize it to be root 16 all over root 7 multiplied by root 7 all over root 7. This will give us 16 multiplied by 7 all over, this is already 7. We all know that 16 is a perfect square. I think I jumped step. I would have just, the answer of root 16 is 4. I would have just leave 4 here and do rationalization. So, but this is a perfect square, which is the same thing as root 16 times root 7 all over 7. So the answer is supposed to be 4, because root 16 is 4. Root 7 all over 7 is the final answer. Now we already have the denominator in a rational form. So this is how you go about your division in surds. First, you can use this division rule. In a case where you can just, that using this rule will not help in anything. Okay, let me just highlight it. Just go straight and rationalize the denominator, and that is it. So let's solve a few examples, and then, so if you go to the textbook, this is exercise 1F number 16. We have root 18 times root 20 times root 24, all divided by root 8 times root 30. So what are we doing? We're doing both division and multiplication at the same time. So the first thing we are going to do is carry out the division on the numerator, division in the denominator, and multiplication in the numerator and the denominator, and after that we are now going to do the division. So let's dive into it. This times this will give us so the rule we use for multiplication is 18 times 20 times 24 all divided by root 8 times 30. We all know how we got to this. When you have individual surd multiplying itself, it's the same thing as all of them multiplying themselves under one surd. So that's how we get. So here we have if you multiply all this out, you have something like 8. If you use your calculator, 640, or this is 240. Now the first thing you have to do is to find that number that that can just factorize this in a way that you get a perfect square and a surd that you cannot rationalize further. So I think if you do that, you have something like I think here is 64 times 9 times 15 all over 16 times 15. So this gives us this and this gives us that. I've already explained so many times in this class how we used to get to this. First, you just need to know your multiples that can give you the same number, while on the other hand the same applies here. So I can now open it again back so that I can get the rational answer. Multiply by root 9, multiply by root 15, all over root 16 times root 15. So you are going to get square root of 64 is 8 times square root of 9 is 3 times square root of 15. Here square root of 16 is 4 times square root of 15. So you get the answer is this is 24, because 8 times 3 is 24, square root of 15 all over 4 square root of 15. So your final answer is can 4 divide here? 4 divided here is 1, 4 divided here is 6, and 15 root 50 can divide itself, so your final answer is 6. So for those of us that want to stay back in the class, and let me repeat how I came about this, you can stay back. Let's go about it. First, you just use factorization and get all the numbers. So let's go about it again. First, the least number that can divide here is 2, so we have 4, 3, 2 divided here is 4, 2 divided here is 3, 2 divided here is 2, and 0. Next is 2, we have 2, 1, I carry 2, 6, 0, 2 again, you have 1, I think 0, 8, 0, 2 here, 5, 4, 0, 2 here, 2, 7, 0, 2 here, 1, 3, 5. Now 2 cannot go anymore. So the next least number is 3. 3 divided here, we have 3 divided by 13, 2. No, 3. No, 4. Carry 1. Here will now be 15. 3 divided by 15 is 5. 3 divided by 45 is 15. Next, again is 3, 5. Then 5 is 1. For you to know those that will give you a perfect square, you take it 2, 2. So here now 2, 2, 2, 2. So we don't have any number that repeats itself. So this is the factor of this number. 2 times 2 times 2 times 2 times 2 times 2 times 3 times 3 times 3 times 15 times 5. So this is how I came about this. So look at it. This 2 multiply itself into 6 places. That's 64. Sorry. That's 64. Then 3 multiply itself, that's 9. Then 15. The reason why 15 is together is because it's not a perfect square. So that's how I came about this. The same thing applies to this 240. Let's do for the one for 240. 2 go here, we have 120. 2 go here, have 60. 2 go here, we have 30. 2 go here, we have 15. 3 go here, we have 5. 5 go here, we have 1. Now these ones are in pairs. Anyone that is in pair will give us a perfect square. So that's how you have something like these ones that are in pair. These ones are not in pair, so it means this will be our irrational root. So 2 into 4 places is 16. Now multiply by 15. So this is not totally necessary, but just a way for those that don't know how to factorize the number in a way that you can get a perfect square and non-rational root. You understand? So the summary is for you to just find a perfect square, and so that when you factor out the perfect square, we are now left with only the least non-rational root in the square root sign. So this is all about division of surds. See you in the next class. Thank you.